All right, let's get started. Let's talk about the planets for a couple minutes just to get that clear that stuff up and any you know misconceptions. The inner planets are Mercury, Venus, Earth, and Mars. Now, Earth is the largest of the inner planets, and it also has the fastest rotational speed, which means its day is the shortest. A lot of people had Mercury down for that. There was some confusion there. Mercury has the shortest orbital period, the shortest year, but the day on Mercury is much longer than the day on Earth. Um, let's talk about Venus a little bit. Venus is really interesting. It is the hottest planet, even though it is second from the sun. Now, Mercury is closer. You would think that would be the hottest. Venus is much hotter. The nighttime side of Mercury is freezing cold because there's no atmosphere really on Mercury. On Venus, the atmosphere is mostly thick carbon dioxide, crushing pressure. It's like living at the bottom of the ocean. The air is that heavy. Um, Traps the heat inside and doesn't let the heat escape from the planet. So it's hot enough to melt lead even at nighttime on Venus. So it's very, very nasty place. Very unlikely anything could survive or live in that place. It also spins backwards from the other planets. That's probably because when the solar system formed and the planets were kind of like forming and colliding into each other, Venus was hit and it rotated 180 degrees around, which means that if it's spinning this way, as you spin it upside down, it's spinning the other way. Kind of neat. So Venus is kind of like, I guess I focused on that a little bit more because it has those unusual things. Now, yesterday's we did the outer planets. People did much better on that, but I kind of want to go over some things about it because we didn't get into a whole lot of detail. The outer planets, once you get far enough away from the sun where the heat isn't as much, the atoms of hydrogen for the inner planets were too excited. They had too much energy from the sun and would escape the space, and they got blown away out towards where Jupiter is. Where Jupiter is, it's cold enough that these atoms move slow enough that they stick together. And as they were clumping together, they grew into this gas giant. Like big clumps would get together and form an even bigger clump. And after a while, you got your gas giants. Um, they're mostly made of hydrogen. Now, at a certain depth, that hydrogen, gravity pushes it together. The pressure squeezes that gas into a liquid. And you have what's known as liquid metallic hydrogen, oceans of this in the center of all these gas giants. Eventually, you get down that hydrogen can be crushed into a solid, which means it's kind of getting close to turning on like a star. If you push the hydrogen close enough together and nuclear fusion starts, it would turn on as a star. So some people call Jupiter a failed star. That's really a bad description of it. But, you know, um, it's fun for some people to kind of say that. Um, Now, Jupiter is by far the largest planet. All the other planets could fit inside Jupiter. It's far, and a lot of people like to call it a failed sun. But um, one of the cool things about Jupiter is it protects the Earth from comets and asteroids. Because of how big it is, it kind of like pulls comets into it, so it hits Jupiter instead of some of the other inner planets. It helps protect them. It doesn't get all of them, obviously. The dinosaurs can tell you that. And if it wasn't for the asteroid or comet hitting the Earth for the dinosaurs, uh, we probably wouldn't be here today. Um, it also has a giant red spot, which is a massive storm, a hurricane, which is bigger than the Earth. And it's been raging for hundreds of years. Since Galileo first observed Jupiter, he saw the red spot and it's been there ever since. So it doesn't look like the storm's shutting down anytime soon. Has many moons, but the four that Galileo saw are pretty interesting. They're larger moons. Io, Callisto, Ganymede, and Europa. Ganymede is interesting in that it is one of the only, it was the first place that we saw active volcanism on another planet. Uh, these volcanoes erupted sulfur, not lava like we have on Earth. But it was interesting. It was the first time we saw active geology on another planet. The most interesting place in the Jupiter system is Europa. Europa is a moon that is basically an ice ball and it's perfectly smooth. All the other moons of Jupiter have craters from Jupiter pulling asteroids in towards it. They're pummeled with these craters all over it. Europa is smooth. When an asteroid hits it, it punches through. Liquid water comes up and freezes. If there's liquid water on the planet, on the moon, the moon, that means the chances for life go way up. This is one of the prime places that we want to send a probe to actually dig through the ice, put a robot kind of submersible or submarine to go down there to look around to see if there's something swimming down there. It's pretty exciting for all of for like us scientists. Saturn, it's a lot like Jupiter, smaller than Jupiter, has great ring system. All the outer planets, gas giants, have rings. Saturn's is the most majestic. It's probably a moon that got too close to Saturn, and the tidal forces ripped it apart, and it's strewn across around in a ring. Most of them, the pieces range from grains of sand or pebbles to about the size of a truck. They're spread out and they're very kind of thin and wispy, I guess you could say. Tons of moons again, but the one that's most exciting is Titan. Titan is a gas, has an atmosphere on it. It is very cold. It's been observed to have organic molecules in the atmosphere. Now, that doesn't mean they're alive. They're made of the chemicals that make up living things on the Earth. So it's kind of viewed in the past as it could be a very frigid early Earth-like type place. And it was hypothesized that there was lakes of methane, not water. Water would all be solid there, and that the different type of life could possibly evolve there that would use methane, much like we use water. When they sent the Cassini probe there, it had a Huygens probe that detached from Cassini and actually landed on Titan and confirmed all the kind of speculation and hypothesis that we had in the past about what it was like on there. We don't see anything living there. The instruments weren't that good, but they could detect the atmosphere, the type of molecules that were in there. It detected the methane seas and everything. Very cool. Go to the other two, Uranus and Neptune. They're pretty similar. Uranus is unusual in that there was probably a collision that turned at 90 degrees instead of 180 where it spins backwards. It spins on its side. So for half of its revolution around the sun, it's daytime. And then for half around its revolution around the sun, it's nighttime at any point on Uranus's surface, which is really unusual. Its ring is kind of sideways as well because it goes in the direction that it rotates. Neptune is unusual in that it is so far away, gets so little sunlight from our sun, but is the windiest planet in our solar system. Wind speeds measured there are way past hurricane speed winds. Winds on Earth are caused by the sun and uneven heating of the Earth's surface. That can't be the case out there. So that's a mystery that scientists are currently working on. Neptune has a moon called Triton, which is has volcanoes on it again, but they erupt liquid nitrogen instead of lava, which is another place that they think life may be possible. That we should check out. Very cool. Pluto, not a planet. Just like different things, when you discover something and then you classify it and then you start to learn more about it, you reclassify it. You weren't totally right at what you thought it was at first. Same thing goes with Pluto. There's a lot of things that kind of tell you Pluto is not a planet. They used to just say a planet was something that was round and went around the sun. They started discovering other objects further out than Pluto, and there seems to be a lot of them in the Oort cloud, which is probably lots of cometary material. So they started to say, let's redefine what it is. So one of the things that a planet is, they all have to orbit in the same orbital plane, kind of like this plate. Okay, you would have the sun in the middle, and then each of the planet is on the same plane as you get further away. Whereas Pluto doesn't do that. Pluto, instead of orbiting around like this, orbits like this. Okay, so it's not in the same orbital plane. So it didn't form in the same way as the other planets did, and the same thing. You have the inner planets are rocky, then you have the gas giants, and then you have Pluto, which is basically more like a comet than a planet. So it doesn't really fit in with the way the other planets went. The major planets have all cleared their orbital path of debris. There's nothing really in there. Pluto still has a lot of stuff in its way that it has to kind of move through. Pluto also comes closer to the sun than Neptune does for part of its orbit. Another thing, so it's more elliptical, the orbit, than the other planets. And Pluto has a moon, Charon, that is about half the size of Pluto. And instead of the moon going around Pluto, they both orbit a point in space like this. It's really kind of weird. So Pluto demoted to a dwarf planet, which means it's still significant. It just doesn't fit with the other planets. Good news for an asteroid, Ceres, when that was discovered, they named it a planet too. But then when they started finding a lot of other asteroids, oh wait, we can't call it a planet with all these other things out there. It's an asteroid. Well, now because it's spherical and fits the definition of a dwarf planet, Ceres is a dwarf planet. So we have about 5 or 6 dwarf planets now in our solar system, which is pretty exciting. A lot of them would have been just ignored as space debris, but now they're kind of in the family just as a dwarf planet. Now, hopefully that clears up the questions about that. Let's go on to the formation of the solar system. You have the Big Bang occurs, the birth of the universe. It expands, it starts to cool, protons form. After about 380,000 years, it has cooled to the point where the protons can capture electrons. The first light moves through the universe. About 1 million years after the Big Bang, we get our first stars, which are really big and they explode. In the cores of stars is where they make the heavier elements, which are the carbon, the iron, the magnesium, all that things, they're made inside the cores of stars. So when these stars explode, they spread that material out. The next generations of stars now have the building materials to make planets around them. Our star is a 3rd generation star. Eventually, about 4.5 billion years ago, a nebula formed that became our solar system. As the gas started clumping together and drawing in towards the center, it started to rotate. Eventually, once there was enough mass and there was enough heat, enough pressure, nuclear fusion started, which pushed back against gravity, and that formed our star. And that's how big our star is. It's the balance of gravity crushing it in and the nuclear force pushing it out. That makes our star. Now, once it turns on, you have a solar wind that comes off of it, charged particles and everything, which is enough to blow the hydrogen, any of the other hydrogen that was around, away. Okay, and blew it out to the outer parts of the solar system. They would become the gas giant planets. The inner stuff, the rockier materials, was a little more, had more inertia, and the solar wind didn't blow that away. But because it was rotating as it was forming, this stuff's all in motion around it. It starts to accrue, they get bigger, they start banging into each other, growing, getting bigger and bigger. Very chaotic, and they grew into the planets that we have today. At one point, there was about 10 or 12 planets in our solar system. 2 were in about the same orbit as the Earth. When they collided about 1 billion years after the sun started shining, they collided and formed a larger planet, which is now Earth. But that collision also threw a lot of material up into space. Now, the ones that didn't have enough velocity fell back down to the Earth and became incorporated into the Earth. things that had too much velocity flew off into the rest of the solar system, and the stuff that had the right velocity became our moon in orbit around the Earth. It also tilted our Earth on its axis, and that's why we have our seasons. If it was straight up and down, we wouldn't have seasons. This bombardment by comets and other things coming in is what brought in the rest of the water after that massive collision, brought in the water to our planet and made it what it is today. So here we go. And I think that's about it. So hopefully you like this video. At the end of the worksheet for this assignment, I'm going to see how much you guys like this, and if you want me to continue doing this or whatever. I kind of like this, so I can clear up some things and you can hear me speak about it. I'm not going to do it every day, but I think once or twice a week would probably be good. Let me know your feelings on it, and keep up the good work. I'm really proud of you guys. Most of you guys are really putting a lot of effort in and doing good work. Keep it up. I'm very proud. Thanks.